Okay, good evening. Hello, everyone. So today we're covering labs one and two. I'll be very quick with this one, mainly because we covered this part once. Unfortunately, we couldn't test for connectivity because of the host file, which was blocking ping replies. Uh, but I think I'll fix that. And this is how we can fix it. You can fix it as well. So basically, if you go to your computer, if you are having problems with the ping from remote networks, local networks, I think it works, but remote networks, that's another issue. So you go to control panel, system settings, you go to the firewall, allow an app through firewall. You can see we have ENSP here. You have the router, you have the switch as well. So we have those two devices. You need to allow them access via the firewall. So if this is deactivated, what basically means the firewall, your computer's firewall will be blocking um, most probably my CMP packets. Therefore, my ping requested won't, my ping replies actually won't get back to the device in a requester. That's why my ping requests were not working. So just to test that, I had set up this network. So you have two my PCs IO. Those two PCs are remotely connected. Reason why there's a router here. Therefore, this is in one LAN. This is another LAN. That's basically what a remote LAN with a remote connection means. All right, we started our devices. So this one is in a network 10. This one is in network 20, 2020. So I can basically ping 192.168, which is not right in 10, 10, right? 192.168, good, 10, 10. So, like I said, the problem last time was with the firewall. Was done reachable, which is which now. Let me check this one. Gateway repo panel. Let me check this one. Gateway repo panel. We still don't have connectivity. Uh, what's the issue now? Let me check router yangu. Nema configurations area. System view. Display. Right. Yeah, my IP address hapana. Okay, so we don't have my IP addresses. And I think that's basically why we don't have connectivity. Yeah. Let me try to quickly put them there. Interface gig 000. 00 is network 10. IP address 192.168.10.124. This one is active. Let me change the other one. One. Let's put 20. That's network 20. This one is not active. Let me save. How do you save configurations? How do you save configurations? Huawei. Hello. Save. It's actually save. All right. Okay, user view. I can quit here. Is this the user view? No, that's the system view. Quit. Nice. Save. Are you sure I want to continue? Yes, thank you very much. Now saving to slot 17, blah, blah, blah. So I think we're good. So I can now ping 2020 192.168.20.20. Voila, and successful. So the key is allowing ENSP router, ENS switch through the firewall, and basically that's it. Right. Now to go a little bit further, Papa Lab Redu. So for our lab, I think I'm not going to repeat this one. The first one, this 1.1. 1.1, we basically introduced how do you set up the topology, how do you go through the basic configurations. Here we're changing the router name. You go to the system view, we have the user view as well. You change the host name here, then IP address, you add an IP address, simple. You first go through to the interface, then you add the IP address. Practice, very important. Then a couple of configurations we go through here, but this is the simple stuff. So I want to start with my configurations, a static routing. Then we finish off with the ones a OSPF. So for those on WhatsApp right there, this lab, I think you could get inspiration from this. Right, so that's the network we want to set up. Data static routing, um, data OSPF, and we'll see how it goes. Right. So for this one, we have three routers, R1, R2, R3. Let me see. R1, R2. So it's R1, R2, then R3. My connections here, we have three here. I'm just going to follow my connections are powerful with this very easy for configure. 3 there, then we have 1 here. So here we have Gig Ethernet 1, Gig Ethernet 1 as well. Then the last one is 4, I think, 4, 3. So I don't think we have 4 here. So I'm going to use 2. Let me just use 2. Mm, Right. So what our network here is, it is this table, which basically shows us the networks that we have on our network. On other one, on the interface gig Ethernet 001, we have network 10.0.13.1. That's the dot zero, that's the network, dot one, that's the interface address of gig Ethernet 001. So we're going to start up with configuring these IP addresses on our interfaces. So basically on, let me see, let me write my networks here first. Okay, let me write my networks here first before I go any further. Right, so 1 is 10.0.13.1. Where is that text? How do I add text? Right. So this is 10. Uh, it's not writing anything. Let's see. something here. 10, 0, 13. Let's just put the network. We know all the interface IP addresses are all the interface IP addresses are .1, I think. It's not all of them. So this is .1. Then R1, the other one is 12. So 3 and we are 12 here. So this network, 12, 10, dot 0, dot 12, dot 0. Then this other one, the last one, inside gonna 2, and gonna 4 is 23. 10, 23 to 0, 10, 0, 23 to 0. Okay, slash 24, slash 24. These are our networks. Then we have let me move this gigaton is 03. This is 02. Can I change this? Or no consult dice. So this is the same as 04 gig 0. It should be 4, I think. Right. Then the other one is a little bit of patience before we start 003. That's the other one. So I'm just labeling my networks angle so that can tag those into my configs. We don't get confused. 10.0 gig 003 and 003. So instead of 002, this one is actually 003. Instead of 003, it's actually 002, the other way around. Right. Then to end on SMIP address, same interface is EDU. So for R1, we have 13.1 or 001 interface here. So here is .1. Yeah, let's just put it .1. Then R1 per 003, it's .1 again. Right. Then to have R2 003, it's .2. Yeah, it's .2. Okay. Then 10.004, it's .2 again. All right. .2 again. That one is probably .1. Okay, R3 is 33. Okay, R1 is 1, R2 is 2, and R3 is 33. Okay, that was simple. There's 3 here. Then we have another .3 here. Right. We're done labeling our network. Now to the configurations. For R1, all of them are off. So let me just do this. I switch on my devices. This is exactly what you're going to be doing as well. I'm going to submit it out this file just to make sure everyone has done it. All right, my devices, I think they've started. All right, so starting with R1, system view. So I go to interface. Let's start with 003. 003 is 10.0.12 IP address. It's 10.0.12.1. Let's first 24. Interface is up. Then to end up 001, same router. It's 10.0.12.13 is .1 as well. So what changes is 13 here. I hope you can see. Someone in the chat, don't want them showing safe. Okay. Yeah, mufana toziva pfureini. Ndimi unevazama, not me. Right. This one is done. Then we go to another router 2. It's actually this simple. System view, gig Ethernet, let's start with 003. Interface. Interface 003, the address is .2, IP address, 1 and 2, 10, 0, 10, 0, 12, 2, /24. Right. Then we'll go to interface 002. I can use the up arrow and just change this 002 up arrow and just change 23 here. Right, that one is done. Then the last router, system view, interface, we have gig 002, gig 002, IP address 10, 0, 23.3, verse 24. Let's turn to the other one. If interface up to the 001, another dot 3, but it's 13. Right. Matrices edu apo ese. Then takuenda pa static routing, but before I go there, let me just display. Let me display the interface. Display OP interface. All right, brief. Just to confirm if I've configured the right IP addresses. Can I zoom this in? I think I can put this here. So my IP address is these ones by 001. And 001 is 13.3, this one, correct? Then this one, 23.3, this one, correct? Then the other router, actually I can browse through here. R2, just check. I see not a shine now display IP interface. Mention in any mode. It's good. Ease of use. Then 002, it's 23.2, this one, correct? Then the other one is 12.2, correct? Turn up R1, display IP interface brief, right? So R1 tine 003 12.1, this one, correct? Then this one is 13.1. Right, my IP address is LUSA. They are correct. So ideally, on a network like this, what we see, what we see is something like this. Uh, just a little bit of understanding could shift that read. So network at 9-ish. Panapa pane network 12.0, panapa pane 23.0. panapa pane 13.0, I think. Right. So routing, the role in a play on a router iri is to discover networks. By default, a router, it discovers these two networks are. It knows these two networks, E network 13 and 12E. It knows them via these directly connected interfaces, but haizive interface network iruki because it's not directly connected to that. So we need to find ways for the router to know what is on this interface. How it does that? One, that's basically routing. So we have static routing, we have dynamic routing. Static routing is manually configuring a route. So ndinoyapa router iri, let's say it's R1. Ndorodza kuti panetwork yakati kuti usvike ipapo unofamba so kuti usvike ikoko. That's basically what a static route is. You manually configure. So all routes are manually configured, they're static. Then with my dynamic routes, example OSPF, you configure a specific routing protocol pamarouters akho, then that router behaves in a way depending on the routing protocol actually, like I say, it advertises my networks. So for example, this one advertises my networks kuti I know this network and this network. You have send information kunoko. Every router advertises its networks until we have what we call a link state database, which is the same on all routers. That's OSPF. Kana marouters ese ane the same link state database. Router 1 kana rauda kusvika to a remote network rinoshandisa via other routers because it has that information on it. So that's basically what routing is. So what we're going to start with, we're going to start with my static routes. So and this I want to try to put my static routes as well as my dynamic routes on this thing. So my static routes at Chaser, I'm going to put my static routes on this one. Let me make this a bit nice. So let's make a sense. So we're basically going to cover both dynamic and static baba. So with this router, we have this one. Let me see if I can replicate a network here. If you put a little bit of practice on this, it's very, very simple. R1, but funny kuti network yangu yazodii. I think takaita lesson has been a week now. I actually said in video ndikuda zvinhu submit kamangwana, but it's been a week. But people still have some complaints. Good for you, or unfortunately, I was a bit busy. So to the network, let me use this one instead. So 10.0.13, 10.0.13, yeah, 10.0.13, 0, 10.0.12, 0, 10.0.23, 0. So on this one is 3, 3, 1, 1, 2, 2. Right. So the static routes, I'm going to configure my static routes on this router here. It won't work. I think OSPF, all the routes have to. Okay, but let's give it a try. Right. So I'm going to configure my static routes here so that we're able to get to this network, Irabai, as well as get to, I think that's the only one. So from R1 perspective, network is unreachable, the Irabai, because I can get to this one via this interface. I can get to this one via this interface. So I only need to get to that network. Syntax. Syntax today, the IP route becomes very important here. So it's just IP route, static, prefix, mask, next hop. That's it. Uh, so hapa I can do this. Okay, hapa I can do this. I quit. That's IP route. Or I can start with display. Let's see the routing table first. Display, it should be display IP route, I think. How do you display the routing table? Display IP routing table. Is this correct? Right, that's correct. So starting with displaying routing table here, I can, okay, someone in the chat, what's new? Yeah, display IP routing table. Well, I feel a little bit happy on what we see. Well, that's good. So that's a routing table already. We can see. I hope you can see this. There is a bit transparent. I just zoned out to say, let's say a bit transparent so that you can also configure over this topology. Hopefully you're able to see it. But basically, routing table really what it shows us, it shows me kuti kana ndiri pan R1, I can get to network in a 10, 12, 0. I can get to network in a 10, 13, 0. Running out of time, 10 minutes. Right. But I cannot get to network in a 10, 23, 0. That's basically what it means. The reason why we can't get there, I think I've explained that. So per routing table, panobuda ma routes, aruzikamane router. If the route is not there, it basically means there is no connectivity. Host is unreachable in a case where you try to test for connectivity. All right, so to configure then the route, so it's IP route, static. Then I can ask destination IP. All right, destination IP. I want to get to this network 10.0.23.0. So it's 10.0.23.0. Subnet mask, I can put 24. Then we have the exit interface. So here you can either put the exit interface or the what we call the next hop IP. Not sure how Huawei calls that, but you can put the exit interface. So basically, when we talk of putting the exit interface, you are saying, if I want to get to this network from this router, I go via this interface. That's basically what you're saying. If I want to get to this network from this router, I go via this interface. Or you can say I go via this interface. You will be using the exit interface. Or you can say, for me to get to this network, I use this IP address. So this is the exit interface. This is the next hop. So this one uses the IP. This one uses the interface. Two different things. This is what we call a directly connected route. The other one is a next hop route. So you can use either, depending on the network. But if you have a point to multi-point network, then using the exit interface is a problem because you might have one exit, but multiple destinations. So if you use this exit, I'll just zero to advertise a route 1 or 2 or 3. I think is on this one also wearing a little bit also deep is a but I know for some of you work with deep is a But anyway, let's configure our route within the 10 minutes and then test for connectivity. Don't know when. So I'm going to use my exit interface. I'm going to use this. You can use either or. Even can it now depends with my matrix. Yekuti kwauri kuti kune bandwidth yakawanda, kune cost shoma, kuri faster and kupi. So I'm just choosing gig 003, gig 003. Don't think we have anything else. Description, preference, you can add route preference. I think those ones, the other parameters that we have here. You can use them if you want a backup route. I think it's part of Malebe why my backup routes. I don't know. You can change that preference or the AD value, administrative distance. But for now, let's just configure our route regular way. Alright, then if I then show the display a IP routing table, I can now see 1023 rapo. 1023 is rapo. It basically means we can now get to this network. Take note of the protocol that we're using is static. Base up direct because these are directly connected interfaces and networks. Then take note of this preference. Okay, I think the administrative distance Huawei and doing as preference. So kuno static route line 60 compared to like Cisco it should be 0. Kuno a static route actually OSPF is preferred than a static route in this the other way. Cisco. How do I get to this network? Yagato is the next hop pana. I think this one is much safer to use Huawei syntax because if we're talking next hop, is that next hop correct? That's the exit interface. This one, maybe it's the language Asiana. Then the interface gig Ethernet 00. Natasa jebweren. Gig Ethernet. Okay, this is the exit interface. And this is the next hop. It's a bit different from what I know about the next hop. The next hop is usually this IP address. But Zandosia, this is Cisco. This is Huawei, another language. Probably the next hop is this one. Right. So network editor with here, we can now try to ping these two interfaces because it's now on routing table here. So ndikaita ping the interface 23.2. I should be successful. If I'm not, kwakungoenderera tonopinda muexam tinezvose kushanda ping inoshandira yes ping works so it's 10.0.23.2 see who play. Oh yeah. Oh yeah. Ooh. Avararamba say three. Let me try to ping this one instead 10.0.12.2. Okay, 10. What will be the issue now? 10.0.12.2. This one successful. Okay. Uh this network. Right. Question, 3 minutes. Why was this not successful? Lanoona networking. That's one a bit late, but it is what it is. Why was ping to this network source not successful? So I tried to ping from this device to this network. Why was it not successful? Any idea why? Chat. Mm, error ping. What's that? I don't know what error ping is. Error P. Error P ya D.
I think nakuisa Malupex.
Malupex ane marauta. Another try. 2 minutes. Let's talk. Malubek ane marauta tuita. Lebrenyu as much as rangari Malubek. Ndizvo zvanga zviriitwa nezvemalubek. A loopback interface is basically a visual interface created on the router, which always stays up. You can always ping that loopback interface because it's always up. And zvatiri kuita apa marausi edu aya, actually lab zvandiri kuita apa palab here hazvina kuitwa pamalabs ese akaitwawo. So I'm expecting you kuti lab renyu richava rine ma-loopback interface, but this one haride. This one rine actual networks, not ma-loopback interfaces. So loopback interface haina any connectivity. Tinokwanisa kuconnecta. Someone, you only configure one static route, ndo ari kuziva, instead of two. Saka kana ndaconfigure one static route, what does that mean to our ping? So ping, it works, it basically means request yedu iri kusvika. Request iri kusvika uko, but the reply has kudzoka because network ish haiziva network ish. So we need to configure a static route rinotisvitsa kunetwork, any of the networks zero. So to configure a static route ready one side. That's the reason why it is in a ping. I can see 1 minute left. Let me just start another session so that we can finish this up.